Okay, welcome to lesson 3.4. This is our last lesson for chapter 3. And again, we're looking at optimization problems. So we're looking at the same algorithm that we used in lesson 3.3. If you've forgotten it, get it out now and put it beside today's lesson as we go through. In today's lesson, our problems are all going to focus on economics. So there's a few pieces of vocabulary that we need. For instance, when we talk about revenue, we're talking about money coming in to a company, just in case you don't have that understanding. When we talk about expenses or cost, we're talking about money going out. And one of the things we want to talk about, usually when we talk about cost, it's usually per item, but read the question carefully and usually there's some clarification. And then usually when we talk about expenses, we're talking about total. So per item would be like per item that they're maybe manufacturing or something like that. Price is going to be the money that is coming in per item. Right, so there might be a cost to manufacture the item and then the price that I charge my customer. Now, profit is going to be how much money I actually get to keep. So it's going to be that revenue amount, that's the total amount of money coming in, minus the expenses or the total cost. When we talk about profit, this could be total profit, or it could be per item. And if you're looking around on the internet, you're going to hear them sometimes talk about marginal costs and stuff like that. But in our course, we're going to just stick with these basic terms. In our first problem, we're talking about a company that's manufacturing nail polish. So again, the item doesn't really matter. You're going to find these questions are all kind of the same. Even in your homework, I think there's one where it's apartments that people are renting. It's the same idea. So we've got a company now sells 2,000 bottles of nail polish a month at a price of $10 each. So that's what's currently happening in the company. But they believe that sales will increase by 250 bottles for every 25-cent decrease in price. There's also a limitation in the factory. The factory cannot produce more than 3,000 bottles per month. And then the question then is, what should the company charge so that they will earn the maximum revenue? So again, we want to look for that phrase, like what are we trying to maximize or minimize? This one's just a revenue, so we're not worried about profit. We're just talking about the money coming in. So we've got a couple of things here. You might want to break down like what information am I given? What information am I trying to find? So what we're given is right now, we make 2,000 bottles a month, or we sell 2,000 bottles a month, and right now it's $10 per bottle. And then what we know is that every time you lower the price by 25 cents per bottle, you're going to increase the number of bottles by 250. But don't forget that that works in the opposite direction. So I can have a 25-cent increase. And if I increase the price of the nail polish, I would see a decrease in the number of bottles that I would sell. And maybe that's actually what's going to give me the best revenue, right? So I need to investigate that as well. I'm just keeping that in mind, that it's okay to have a negative decrease. That would just be an increase. All right, when we have this type of, and don't forget here, if we're maximizing revenue, what I want, my goal here is to find like R equals some stuff, and then I'll take the derivative of that. So the thing that's changing in this story, the unknown here, is the number of times I'm going to decrease the price. So my variable, so I'm actually going to kind of start my solution now. My variable, I'm going to call it X, and it's going to represent the number of price decreases. So I want you, I normally wouldn't write this, but let's think about what does that mean. So if x is equal to 4, then that means I'm decreasing the price 4 times. So I'm going to take the price of $10 and it's going to be 10 minus 4 quarters, or 10 minus $1. So the price would equal 9. Now imagine what happens if x is like -2. Well, then the price would be 10 minus, or sorry, plus, let's do that again. It'll be minus -2 times. And all that means then is I'm adding 25 cents twice. So I end up with a price of $10.50, and that makes sense, right? Like that's a reasonable thing to happen. So negative values for my x's are okay in this problem. Sometimes we get into the habit that it's not okay to have negatives, and we think that's going to help me find the domain, but here negatives are okay. So let's keep going with the problem then. We want to come up with an equation for the revenue. So I'm just going to think this through with words first. I know that the money coming in is going to be the number of bottles that I sell times the price that I charge per bottle. That's the amount of money coming into my company. So now I'm going to try and change these all into equations. The number of bottles that I sell, well, right now I'm selling 2,000 bottles, right? That's my current. And what's going to happen is I'm going to increase by 250 bottles every time I have for every time I decrease the price by 25 cents. So whatever that X value is, I'll multiply it by 250 bottles and I'll add that to my 2,000 bottles. Now to come up with the price equation, the price right now is $10, and X is the number of times I'm decreasing by 25 cents, so I'm just subtracting 25 cents X times. And now what I have is an equation for the revenue in terms of X. And so I do have another sentence, another let statement that I need to squeeze in here. Let R represent the total revenue. All right, and again, this stuff here was kind of my thinking as I got started on the question. This is where my official solution starts. All right, so now I have my equation. I need my domain. We've already discussed the fact that it's okay for x to be negative. So how are we going to figure out the endpoints of my domain? Well, what I'm going to do is take each piece of my equation and ask myself, what are the limitations on that piece? As well as this question gave me a limitation on the factory production limits. So I'm going to include that one as well. So the first thing I'm going to think about here is the number of bottles. Now the number of bottles I sell cannot be negative. That wouldn't make any sense. So the number of bottles has to be greater than or equal to 0. But I know that the number of bottles is 2,000 plus 250x. And then I'll just rearrange and solve this for x. Remember, when you're solving an inequality, you want to watch out for multiplying and dividing by negative numbers, and then you would have to flip this inequality sign around. And so here I get -8. So I have a lower bound here. I know that my x number has to be bigger than -8. Then I'm going to move on in my equation. The next thing I was looking at was the price. So I'm going to ask myself, well, what would make sense here for the price that I charge the customer? Well, it can't be negative. I'm not going to pay them to take the bottles of nail polish. So my price here is going to be limited by 0. And again, I'll rearrange this. And so here I am going to have to divide by a negative coefficient. And when I do that, as soon as I divide out that negative, I'm going to have to flip the sign over. So over here I'll have and that comes out to 40. So that's all I have to think about in my equation, but I also have to remember that there was a factory limit. So the factory limit, and this came in the story at the start of the question, is that the factory cannot produce more than 3,000 bottles a month. So this is telling me that the number of bottles has to be less than or equal to 3,000. And so again, the number of bottles was 2,000 plus 250x. And I'm going to rearrange and solve this. All right, so this is kind of confusing because we have these 3 endpoints, which doesn't make sense. When I think about a domain, it should only have 2 endpoints. So I want you to imagine the number line here. And we're going to talk about what are the 3 different pieces that we have here. So I've got -8 in my first restriction here, and it says that the x values have to be bigger than that. So it tells me I gotta go to this side of -8. And then the second one here says you have to go, when you're at 40, you have to be less than 40. And then this one here, this last one says, well, when you get to 4, you gotta be less than 4. So I gotta ask myself, well, where am I passing all 3 tests? So obviously if I'm out here, I'm not passing any of the tests, so this stuff is all bad. And then if I think about being out here, obviously I'm not passing any of the tests, so it's all bad. Well, I'm passing the negative, I'm greater than -8, so I guess I am passing 1 test when I'm on the outside. When I'm in this range here, I'm passing the test that I have to be bigger than -8, and I'm passing the test that I have to be less than 40, but I'm not passing this test. So the factory limit would be, I would be outside of the factory limit. So this stuff here is also not allowed. And so here I end up with my domain. It's got to be between -8 and 4. You don't have to show me that number line in your solution. It's just to kind of help you figure out which values to take. And so if I have to be less than 40 and less than 4, then you have to be less than 4. All right, so now we've got our domain. We've got our equation. Let's go back up to it. It's way up here. I'm going to take the derivative of this. So I'm going to use the product rule here instead of expanding because I actually find it easier. So I'll take the derivative at this point. I'm into my algorithm now. Taking the derivative of the first bracket, so I'm thinking of this as f times g, and I'm thinking about, remember that the product rule tells me to do f prime g plus fg prime, and so this is kind of in the back of my head as I work through. Taking the derivative of the first bracket, I get 250 times the second, and then plus, leave the first bracket alone, times the derivative of the second. All right, so now that I have my derivative, I want to set it equal to 0 so I can find those horizontal tangents or the local maximum and minimums. So I'm going to expand this all out and try to refactor it because there's no common factor here. So here I've got this negative 0.25 that I'm multiplying forward into the bracket. And then I'll collect like terms. All right, so I'm solving for my x value. And I get x equals 16. Which unfortunately is actually not in my interval. Remember that my interval went from -8 to +4. And so what this means is that if I were to do 16 price decreases, I'd be outside of that factory limit there. So I can't have that. And I'd be selling too many bottles that I'm not capable of making in that factory setting. So now I only have to check 2 y values. Oh, sorry, -8. So when I plug -8 into the equation, remember that came from making the number of bottles equal to 0. So it's going to make this first bracket equal 0. And then I'll just have the second bracket left. And so the revenue will be 0. And then checking out that factory limit. So this one's coming from the fact that I can't make more than 3,000 bottles. And again, I'll plug that in. And when I calculate that, I come out with $27,000. That sounds better. Now the question here asks me, what should the company charge so that they earn this maximum revenue? So for my summary statement, I do have to figure out what the price is. And remember from up here, our price equation is this second bracket, 10 minus 0.25x. And so I am going to be subtracting $1, and I get $9 per bottle. Okay, our second example is about some wood stoves. So Apple Appliances can sell X hundred wood stoves when the price per unit, so a couple things I'm already noticing here. So X hundred wood stoves is how many they can sell. When the price per unit, so this is the price for one wood stove, is given by 350 minus 5x. If the total cost, so now we're looking at total cost. So let's see here. We've got the price per unit is this, and the total cost of making and selling the stoves is given by this. We want to find the greatest possible profit. So what this question is asking me to do is maximize the profit. And so I know eventually I want an equation for the profit. And then in my summary statement, I'm also going to list the number of stoves. Okay, so if I want an equation for profit, then I definitely need a variable for that. I don't need another variable because they actually gave it to me here. They already defined X for me as the number, as the number of wood stoves in hundreds. So I'm going to come up with my equation now. I know that profit is equal to the revenue minus the cost. And the total cost here. They're giving us the total cost as an equation here, so I'll write total cost even though we said it was expenses over there in the definitions. So we want the total revenue minus the total cost. So the total revenue is going to be the price per unit times the number of units. And then the total cost they actually just gave me, that's the C at X equation. So again, to find the price, they gave me an equation, little p at X. And now what I need to know is to figure out, well, how many units are there? Well, it's going to be whatever the X number is. So let's say X is equal to 2, then that means that there's 200 stoves. So the number of units is going to be 100 times X. And then we're subtracting that cost equation. So now I'm going to sub in those two equations. And at that point, I'm going to have a profit equation in terms of X. Don't forget you're subtracting that whole cost equation, so I'm going to have to distribute that through. All right, so one of the questions that I would normally get in class about this one is how much of this do I have to show? And I do find that a bit of this is actually helpful when you're coming out with the domain. So I would suggest that you show at least one of these 3 lines to help you out with the domain. And then, of course, you do need this line here with all the equations. All right, so we've got our equation. We still need our domain. So I'm going to come off to the side and work away on my domain. So I'm just going to kind of draw a line down my page to keep this separate. So when I'm working on my domain, I'm thinking about each of these kind of sections in my equation and if there's limitations on them. So for instance, the first one here is the price per stove. And of course, I'm again never going to charge a negative price for my stove. So the price has to be greater than or equal to 0. So our price equation has to be greater than or equal to 0. And again, don't forget when you divide out that -5, you have to flip the inequality around, and I get x is less than 70. The other way you could have done this was to actually add the 5x to the other side of the equation, and then you would have ended up with 70 is greater than or equal to x, which is the same thing as what I ended up with, just in the opposite order, right? Here, the mouth of the greater than sign is still opening towards the 70 in both cases. All right, so we've got one limitation on our domain. The next piece of my equation is the number of units. And again, I can't sell a negative number of units, so the number of units has to be greater than or equal to 0. Here, this equation is rather simple, so it actually comes out that x does have to be greater than or equal to 0. And then there are no limitations in my equation. The other thing is the cost for the company. So the total cost is typically never going to come out to be negative, but it would be okay. It would mean that you were making money, so maybe they somehow included some revenue in that cost equation. But it would be okay for cost to be negative, so I don't really come up with limitations from that piece alone. So I've covered everything in my domain. There was no like factory limitation in this question, so I have here that my x value has to be between 0 and 70. All right, so we're going to keep going with our equation over here. Now that we have that, I do want to take the derivative of this. We can simplify this guy first, or you can take the derivative of the pieces. Either way, you're going to come out with the same answer. So I'm going to take the derivative of the pieces here. You're welcome to expand, simplify, and then take the derivative as well. So taking the derivative of the first piece here, so I've got like an f times a g, and I'm going through the product rule. Taking the derivative of the first bracket times the second bracket plus the first bracket times the derivative of the second bracket. And then over here, I'm subtracting, and I'm going to take the derivative of each piece here because it's all addition and subtraction. All right, and now I need to simplify this guy because I want to know when does this equal 0. So I multiplied the 100 into that bracket, and I multiplied the negative into this bracket. And now we're going to collect like terms, and I get negative 1250x and plus. All right, so now we'll solve for x. And that comes out exactly to 21.6. So I'm going to leave that there as a decimal. All right, we've got our x value. It's in our interval, so I need to check all 3 y values. So when I plug p equals 0 into the original function, I'm going to get 0 minus, so I'm doing a bit of simplifying here when I plug this one in. 0 is usually really nice to plug in. And then my other endpoint is 70. Sorry. So I'm going to plug 70 in. Where am I? And this is bad news. They're like losing money like crazy. So their profit is actually negative $1 million. So that's not good. You don't want a negative profit. It means you're overall losing money in your company. And same thing up here, they were losing money. And yay, they finally made some money here. So this is what we want. And then the other part of the question is asking me, well, how many stoves? So I actually calculated the number of stoves here, but just to be really clear in my solution, the number of stoves, remember up in my equation we said was 100 times x, and so it's 100 times 21.6, and that gives me the 2160. All right, have fun with the homework, guys.